Yo guys, so let's continue in finance, ne? Present value annuity. So here you have regular payments, ne? Regular payments, same amount of course, which will be paid, right? But now you are paying back a loan. Yeah, well, so it's like you took a loan and now you're paying it back, right? Or a bond, now you're paying it back, right? Yeah, that is present value annuity. Right? So you're not saving money for the future, or you're not saving money to yeah, you're not saving money for the future, right? You're not saving money, right? What's rather happening is that there's you are making a payment, right? So I'm also saying that for future value annuity, what's happening is that it's like your bank is increasing in a way, because you are depositing money into your account, right, to get to a particular amount, right? But here you are taking money from your account to pay the bank or someone else that you owe, right? So you're taking money from your account, yeah, and to make payments, right, to the right candidate. I don't know. Yeah, so it seems like that's one other unique I haven't thought of it that way, but yeah, it makes sense, right? So this is how this video is structured. We're gonna do the derivation of the formula, then we're gonna use that formula solving a couple of examples, then we go to the last video, which will be about the exam question, right? Cool, let's cook. So here's a beautiful scenario, né? Imagine that for the next 3 years I want to withdraw 1,000 per year, ne? Yeah, in the next 3 years I want to like withdraw money, and I want to withdraw 1,000 rand per year for 3 years, ne? Cool, that is what I want. Now the question is, how much should I deposit into the account right now, ne? How much should I deposit into the account right now? You see, so let's make those calculations, ne? Before those calculations, perhaps I can do smaller timeline. Okay, yeah, smaller timeline. So I need some cash that I'm going to deposit here. Let me call it, I don't know. Okay. Then there is like here one. This is T0, of course. Then T1, T2. Okay, T3, right? T3. I'm growing up in there. I'm growing up in the Lord. Da-da-da-da-da-da. Cool. So here we have this is gonna be what's happening. Okay, this is gonna be 1,000 rand, right, that I'm withdrawing, and then there's gonna be 1,000 rand that I am withdrawing, and then there's gonna be a last 1,000 rand that I am withdrawing, right? So now I'm asking you a question: how much money, right? How much money must I deposit right now? That is K, right? K is the amount of money I'm gonna deposit right now that will enable me to actually be able to deposit 1,000 rand each and every year for 3 years, and yeah, and be done, right? So the thinking, you could start thinking about it step by step, ne? To say, okay, cool, for the first 1,000 rand, if there was amount of money, so we can, for each and every withdrawal, we can determine how much money we must deposit for each individual withdrawals, ne? So I would go with these colors like this. For this one, right, you have A equals to P into 1 plus I, right? And then oh yes, so, and then say, like, for example, the I love 10%, so I'll just say the account at which I would be depositing this cash offers an interest rate of 10%, right? Cool. So now look at what I'm saying, okay, I want to withdraw 1,000 rand, so I want to have 1,000 rand at the end of the duration, and I have P, so a 0.1, and then this is just gonna be for a year, right? Cool. um cool. And now finding this, right? In fact, bro, let me do this. I'm trying to find P, right? At least, yeah. So you guys know I'm trying to find P, which is the money that I should invest right now. So I can just say that P equals A divided by, uh-huh, yes sir, yes sir, right? Another person can just write it as A into 1 plus I, right, minus N, right? There's another way to write it. In fact, let's write it that way. Therefore, for this, the first P will say P equals to, you need 1,000, right? And 1 plus 0.1, right, to the power of -1, right? This is just for year one, right? Just for 1 year, because they say for this 1,000 rand, there's amount of money that I am gonna deposit now that will give me 1,000 rand, which I'll be able to withdraw at the end of 1 year. So we do that. 1,001 plus 0.1. Oh no! Oh, to the power of -1. In fact, I can do this. No. Oh, come on, bro. Stop ruining the fun. Yeah. So when I do this, and I raise it to the power of -1, then I'm getting 909 and 9 cents. Right. That's how much actually I should invest, right? I mean, I can just show you now. Say 909.09 into 1 plus 0.1. Right, look at the value. You round it off to the nearest two decimal points, because coins, cents is like 2 decimal points. You get exactly 1,000 rand, right? So cool. So now let's go for the second withdrawal. How much money must I invest? So there's an amount of money here which will stay for year one and year two. Year two, I withdraw the whole cash, and the whole cash will be 1,000 rand. So it's gonna be the same. I'll go for this color. So it's gonna be, therefore P is gonna be 1,000, right, into 1 plus 0.1, and then here is gonna be -2. Why -2? Because the money that we invest, right, has been here for 2 years. So it's a first year, then second year. So that's why. Remember, this is like having -2 here, right? Or it's like you have 2 here. So but when you divide by 1, when you divide by the whole bracket, right, you're gonna end up with, yeah, cool. So 0.1 to the power of -2. Hey, wait, no man, -2, bro. Yeah, so -2, and I'm getting 826.45, and just as tested, 826.45, 1 plus 0.1 squared. See? Cool. Then there's this last amount. I'm like, okay, for this money, how much must I actually invest, right? So remember, now we're thinking about these amounts one by one, Jane. It's like, okay, if I want to withdraw 1,000 rand in 3 years time, how much must I invest now? So the one we just did now, it was like, if you want to withdraw 1,000 rand in 2 years time, how much must you invest now? And this is the amount we must invest right now. This one is the amount we must invest right now if we want to withdraw 1,000 rand in 1 year's time, in a year's time. So here it's gonna be sort of the same thing, the same idea, right? But of course here it's gonna be what, -3, because 3 years, right? 1,000 into 1, let me just say 1.1, because yeah, 1.1 to the power of -3, right? And we're getting 751 rands, right, 31 cents. Cool. So now, right, therefore I will then say, therefore, it's a lot of colors, man, I'm sorry for that. Therefore, I don't know what I should write. Total money that I must invest. Money, right, to be. Oh. Deposit total. Oh, yeah. Deposit amount, bro. Deposit. Deposit amount. It's just gonna be 90909 rand plus 826.45 plus 751.31, and then oh my god, this is gonna be so nice. 826.45 plus 751.31. Cool. So therefore the total amount that I must invest right now, it's 2,486, right? And then 85, ne? So this is the amount of money that I must invest right now, ne? Cool. So I'm gonna show you something now. So say I invest this money, ne? I invest it for 1 year, ne? I invested for a year, 2,486.85. If I invested for a year, after that 1 year period, I'm gonna have guys, so here it's plus my interest, ne? And then times 1 because it's by year. So here inside the bracket it's gonna be 1.1 from 1 plus 0.1. So I'm just gonna say 1.1, right? Yeah. And the money I will have at the end of the period is gonna be come on, bro. It's gonna be 2486.85 times 1.1, right? I'm gonna have 2,735 rand. And then there are 54 cents, right? And then I subtract my 1,000 rand minus 1,000, ne? This is after like a year, ne? So I subtract that 1,000, so subtract the 1,000, right? And I'm gonna have 1,735.34 man 54, right? So now I take that, I'm like 735,454, right? And I invested for a year, right? I'm going to get, so 735.54 times 1.1. This is how much money I'll be having. Come on, bro. 1,909.09, right? And then I withdraw the 1,000, right? 1 2 3. I'm gonna have 909.09, right? And I don't have to say it, bro. So if I take that 9,009.09 times 1.1, right? Look, 1.1 times 909.09. Right, I am getting exactly 1,000 rand, right? After rounding it up, and of which that 1,000 rand I withdraw, and then I have 0 rand. So you see this amount, ne? That value, it works, ne? So from that value we are able to answer exactly the question. Yeah, I was taking it slowly, ne, for the derivation of the formula. I was taking it slowly so that you guys understand this, ne. So now let's get to the real derivation of the formula. Now we understood all of this and how it works. Now we're gonna go further. Yeah, so I wanna get rid of these values. And then all of these values, I'm gonna put them up there because we're gonna need them. Cool. So right, so you guys have now seen that 2,486, right? 86 rands 85 cents. This much is equals to 909.09 plus 826.45 plus 75131. That's what you guys have seen right now. So now the thing is, these values now, okay, this thing is now, it's like a series. Yeah, one, it's like a series, because the thing is, how did we get these values now? We got them by saying here it was 1,000 into 1 plus 0.1 negative 1 plus 1,000, right, into 1 plus 0.1 negative 2 plus 1,000, right, 1, let me say 1.1 0 negative 3, right? So this is how we actually got it, né? And you see that, okay, there's a series, né? Because yeah, it's a series. As for which series, let's test it out. Right, so we will find it's a geometric series, of course, but we just want to be sure. So you'll do 3 over t2, which is gonna be 1,000, right? 1 plus 0 0.1. I just wrote it as 1. I didn't write it as 1.1. So you have minus 3,000, 1 plus 0 0.1 minus 2, right? The thousands are gonna cancel each other, so you're gonna have 1 plus 0 0.1 minus 3 minus 2, right? When we divide in the same basis, we're gonna subtract the exponent. So this is me subtracting the exponent, which is minus 2, and then you're gonna get 1 plus 0 0.1. This is gonna be minus 1, right? Let's test it for the last time. 1,000, okay, 1 plus 0 0.1 minus 2, and then 1,000, 1 plus 0 0.1 minus 1, right? It's gonna be the same thing. You're gonna have 1 plus 0 0.1, right, into minus 2 minus 1, right? This is gonna be 1, yes, right, to the power of minus 1. And you see that this thing, we see, of course, they match, so that means constant ratio, right? Therefore it's a geometric, right? And you can see that this is like, let me show you, 1 plus 0 0.1, right, to the power of negative 1. It's below 1, right? So with that being said, let me erase this. With that being said, we can say r, ne? So r is equals to 1 plus 0 0.1 minus 1, right, which is below 1, right? And we have a, which is 1,000, 1 plus 0 0.1 minus 1, right? So with that being said, we know that if we want to find Sn, we're going to use this formula a into 1 minus Rn, close bracket, 1 minus r. And the reason we're using this formula is because r is below 1, right? R is below 1. Remember, if r is between minus 1 and 1, we're going to use this formula for the sum, right? So therefore you're going to have a, which is 1,000, right, 1 plus 0 0.1 minus 1, that is a, and then I have 1 minus r, which is, my r is going to be there we go, 1 plus 0 0.1, right, minus 1, and then multiply by n. What was n here? N, it was 3, because 3 is, né? So let me say 3, right, close my bracket, and then I still have 1 minus 1 plus, okay, yeah, cool, just like that. So then I'm gonna have let me see, is there any further way of, okay, so I'm gonna have on top, I have 1,000 into 1 plus 0 0.1 minus 1, okay, still minus, it's gonna be 1,000, bro, I'm not gonna do this. Look, I thought I was gonna make it long, but let me just press the calculator. 1000 into 1 plus 0.1 um 0.1 okay, yes, then into 1 minus open 1 plus 0.1 close minus, okay, let me see 3, then close, then this is just gonna be 0.1. I bet. Yeah, no. Oh, this, should this be negative? No, 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 no. Probably I did something wrong the calculator, because I must get exactly this amount. So let me go check. I have my 1000 rand, and okay, it's 1000 into this, so power of minus 1 multiply by this into 1 minus, yeah, minus 1 minus, yes, so I have 1 plus 1 to have minus, so it's gonna be minus 2, yes. So we close the bracket, then here in the denominator we have 1 minus 1 okay, let me just say this, so 1 minus, then is 1 plus, all right, and then let's not forget the minus 1 here. So let's put everything in the calculator. We put everything in the calculator. 1000 there, right, and there's just a minus 1 remaining here. And when you put exactly this whole thing in the calculator, you get 2486.85. And I want us to look at this value and compare it to the answer we got, 248685. Here's the value, right? There's the value we got, and there's the value we get when we use this formula, right? So what does that mean? This means now we have arrived at the derivation of the formula, right? What does that mean? Cool. That means for our case, then for our case we will do this. R, it's going to be 1 plus I, right, to the power of what? To the power of minus 1. And then as for A is going to be, this is X. Oh, no, 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 this is the amount of money we deposit. No, we are withdrawing, right? The same amount of money we were withdrawing. So let's call it X, X is the amount of money we will be withdrawing from our bank to make the payments. So you have X into 1 plus I, right, to the power of minus, right, cool. And then, n is still n, right, meaning number of years. So when we take all of those and we now apply it in a Young formula, you're gonna have Sn equals to, so Sn equals to A is X 1 plus I minus 1, right? And then you have into, you have 1 minus R is gonna be 1 plus I, then you have minus n, right? The minus n is the minus 1 here and the n, because we raise it to the power of n, right? So yeah, and then divided by, you're gonna have 1 minus R, which is 1 plus I minus 1. Go. Minus 1. So now we do the working. Let's do the working. It's just simplifying this, and then yeah, after we have simplified this, you'd end up with something really cool. All right, so you know that if I have X, now if I have X to the power of minus 1, this is the same as 1 over X, right? And therefore if I have 2X 2a, right? Maybe x minus 2 is the same as me having 2a over x squared, right? So I'm doing this illustration because of this minus 1 here, right? Just to say that what we have there in the denominator is going to be the same as us having x 1 minus 1 plus I, and then you have minus n, right? And then this now it becomes our denominator with just right, but the negative now becomes positive because we've converted it. So yeah, then you have 1 minus 1 plus I minus 1, right? Cool. So yeah. The numerators just remains the same. There's nothing further you can do. As for denominators, you have, so this multiplied by that is just gonna be 1 plus I, right? And then there's a minus, and then here you're multiplying the same thing basically with minus 1. This one is 1. When you add the exponent, you're gonna get to 0, so this is gonna be 1, right? That's gonna be 1, and therefore you have x 1 minus 1 plus I minus n, and then basically here we can remove these brackets, and then you have 1 minus 1, implying that you will be left with either side. And this is the formula we use for a present value. In fact, for present value we use the letter P instead of letter F, right? So yeah, this is the derivation of the formula. I decided to cut the video here, and the next one we'll do questions. Alright guys, so we have a question here. He still wants to buy a small one farm, and it costing 8.5 million. So he plans to sell his current home for like 3.5 meter, which he will use as a deposit to purchase the farm. He secures a loan with that bank to repay the loan over a 10-year period, with that interest being charged on the with that interest compounded monthly. Cool. So calculate the monthly, right? Cool. So remember, now we're calculating the monthly repayment. So let's remember, our guy wants to buy this, right? But he has this and he uses it for deposit. With the remaining amount, he makes a loan. He takes a loan from this bank. So we can just say 8.5. Let's just say 8,000. Yay, 8 meter. I'm just gonna say 8.5, bro. 8.5 meter minus 3.4 meter, and that is going to be what? That is going to be 5.1 meter, right? So this is how much, this is the loan that the guy actually took, and we need to calculate the monthly, right? So we know the formula is P equals to, you have x 1 minus 1 plus I minus n, right? And then you have I. This is the formula. Now we substitute. Substitution is so you have, oh, by the way, you are actually looking for P, ne? So because we're looking for P, so x is going to be let me see. Okay, it's going to be pi. P times I, and then you have 1 minus 1 plus I minus n, right? Cool. That's gonna be minus n. That's gonna be the formula, and then P, it's that 5,100,123 multiplied by, the thing is 9%, so 0.095 over 12 because it's compounded monthly, right? So we have the straight line, then you have 1 minus 1 plus I minus, oh, look at me not putting it, actual value 0.09512, and then here it's going to be minus 12 times 10. Apparently cool, that was neat. So we have 5 1 1 1 1 1 times 0.095 over 12, 1 minus 1 plus 0.095 12, close brackets, to the power of minus 120. So this dude is gonna have to pay 65,000 rand, or actually even close to 66.75. So yeah, this is how much the guy is gonna have to pay per month, right? Yeah, and then the second question is like, determine how much interest he would have paid on the loan. Oh, by the end. Okay, so now we're trying to find the interest that he would have paid. So to usually calculating these problems, you're like, okay, if this guy didn't take that loan, how much would he have paid? It was this much. If he didn't take the loan, this is how much he should have paid, right? But now he took the loan, right? So he's paying this times 10 times 12. So we need to find the value for this, né? So I'll make some space. So what he paid, total amount paid is going to be 65,99275 multiplied by 10 years, right? And each month, so that is going to be 65,992.75 times 10 times 12, right? So that is 7,919 and 94. You see, I said 94 and I wrote 92. It happens, bro. It happens. So yeah, and I don't like it, but yeah. So this guy ended up paying this much amount, right? So now to find the interest, you'll just say interest is going to be the difference between those amounts, right? So 7,919,094, right, minus 5,1,0,0,0, right? So you realize that the difference is going to be 2,819,094. Let me actually test it out. Minus 5,1,0,0,123. Yes, 218. Yes, so this is then the interest that our guy paid, right? Meaning that if he did manage to have 5.1 meter without actually borrowing it, he would have saved almost 3 million. He would have saved almost 3 million. Let's see the next question. So the next question, it says this person arranges a bond for 17k, right, from Langa Bank, and then the bank charges is like 60% compounded monthly, and determines we have to determine how much money she'll have to pay every month, right, to pay back the bond over, right? So it's gonna be the same thing. So since we derived the x, we can just use it here. 1 minus 1 plus I minus n, right? And it's 17,123 times 0.16 over 12 because compounded monthly. 1 minus 1 plus 0.16 over 12 minus 12 times 9. Right, a bit straightforward, and I think it was because of the previous question. Time is 0.16. 12. 1 minus 1 plus 0.16. 12. And close bracket. And then to the power of negative 12 times 9. Then 200. 297,000. Oh, hey, bro. Yeah, you know when you have a lot of money. 297, 97 rands and 93 cents. Yeah, so that's how it's done. We now have the money that he will, that Ziande will be paying like every month. Yep. Next question is like, what is the total cost of the bond? So now she is paying 297.93 every month for 9 years. So that's basically how you answer it. So 297.93, she's paying it every month and for 9 years, right? So that means 32,176 and 44, right? So, and if we can ask the same question we asked last time to say what's the interest, you will then say this amount minus 17k, which you will realize that the value is, let me see, we have 12,000. It's gonna be 15,000 a couple, right? It's gonna be 15,000. So she paid 15,000 extra, right? Cool. Cool. So the next question, what do we have? Okay. The gang. Cool. So the gang has just arrived. So she has started a new job and he wants to buy a car that costs that much. She visits the Soweto Savings Bank where she can arrange a loan with that interest component monthly. So yeah, she has enough money saved, cool, to pay a deposit of 50k, and she arranges a loan for the balance, cool, which is paid over 6 years. Okay. What is a monthly? Okay, how much? Cool. So guys, listen to me carefully, right? Yeah, so the thing is, I'm already seeing that this question is exactly the same question as the last two examples. So I'm not going to do it, but I'm going to give you an idea of how it's going to be done. So here when they say calculate the monthly installments that she's going to have to pay, the thing is, so there's a 50,000 rand deposit that she has already. So she's gonna pay that. When she pays that, you take the 232,000, and then from that 232,000 you subtract the 50,000 rand deposit. The balance is the total amount of the loan, right? It's how much a loan she took, right? Because after paying the deposit, now she doesn't have any money. Now she goes to the bank to get the loan. So with that loan, we're going to use that amount to find X, which is the her monthly repayments for the loan. Yeah, one. And then when they ask you like how much will the car cost, right? Wait, how much will the car cost? Okay, how much is it gonna cost her now? So now remember, like, you now have from question one, you have exactly how much money she will be paying per month. So you can take that money, multiply it by 12 to find out how much she's paying per year, and then multiply for 6 years to find out how much is paid over 6 year period. And then you're gonna add the deposit on top of that. Then you have the total amount of how much it costed the game, right? So you will have the total amount of money that it cost the game, and that money, it's not the value of the car, it's how much the car cost her for the payments, right? So cool. Let's see the next one. Hopefully it's a different one. So yeah, the bank, it offers a loan at that much. compounded twice a year. Cool, that is a cool. And then so Luba Bale. I'm just gonna say Luba. So Luba borrows 33,000, and they must pay 334 rent every 6 months, right? Until the loan is fully paid. Then the question is like, how long will it take to repay the loan? So the formula. So here I'm thinking we're going to use logs, ne? And for us to actually do that, I am gonna say the next step we're gonna have, because we're gonna have p times I over x, which is gonna be 1 minus, right? And then we're gonna have 1 plus I minus n. Then you have 1 minus pi over x, right? And then from here you can then say you're gonna have, okay, you can then say minus n is going to be log your base, which is 1 plus I, and then 1 minus pi over x. So this is just me trying to make minus n subject of the formula, and I'm using these because you guys have already done logs, so you know the rules of logs, right? So if I now substitute, it's gonna be 1 plus, right? So remember, this is the rate and it was twice compounded twice a year, so it's gonna be 15 0.1563 divided by 2, right? And then for the big one, we're gonna have 1 plus 1 minus the money she borrowed, 3,000, right? Multiply the interest, which is 0.563 divided by 2, and then dividing by the money she is paying per month, which is 334,334,93, right? And therefore minus n is gonna be, we have 1 plus 0.1563 over 2. Oh, by the way, nah, by the way, this example is gonna be 2 here, right? Like, because it's compounded twice a year, right? So this is gonna be 2, because remember we would, if we knew what n was, we would have multiplied it by 2. So yeah, so yeah, for this one we have 2 here. So divided by 2, that is done. So now I go here, I have 1 minus 3,000 times 0.1563 over 2, right? Cool. Perhaps I needed a bracket here. Yes. Then I can put 334.93, yes. And I am getting minus 16, right? This is just minus 16 when you round it off, right? And therefore n is going to be a. So yeah, she's gonna actually spend 8 years paying for that, right? And they ask how much interest will she pay for the loan. So you guys know the drill. Cool. I shouldn't have removed it like that. Let me just do this. Goodness, son. So she remember she's paying 33493 twice. She's paying it twice a year, and she's gonna pay for over 8 year period. So it's 2 times 8 times 334.93. This is how much she's paying total. 5,358.88. Right, but initially she had borrowed 3,000, so that means 3,588. So we're gonna subtract 300 rand, 3,000, and therefore 2,358.88 is the interest. Right, it's the interest for this question. Right. So yeah, present value annuities are quite easy once you understand the formulas and how it works. Right. So yeah. So let's see each other on the next video, which is for the exam questions.